Hey guys, welcome back. Today we are getting into Unit 1, which is all about atomic structure. So we've gone through our intro and now it's time to get into some actual chemistry. So today we're going to focus on the atom and our objective, we're going to be able to characterize protons, neutrons, electrons by their location, relative charge, and their relative mass. So basically by the end of the day, you guys will be able to basically tell me what an atom is and what the different components of the atom are. All right, so first we have to talk about what is an atom and what are the components. So the atom is the smallest unit of an element that retains the property of that element. So it's the smallest unit of the element. There are two areas of the atom, the nucleus, and the nucleus is going to be in the middle. So kind of like the nucleus of a cell. If you think back to biology, how the DNA is in the nucleus is kind of the center, the control center of the cell. The nucleus is going to be the center of the atom. And then the electron cloud is outside, and this is the location of the electrons. The nucleus, so we're talking about the center, the nucleus contains two subatomic particles. That's the protons that have a positive charge, and that's pretty easy to remember because P and P are the same. So protons, positive charge, and also the neutrons, which have no charge. So think neutrons, neutral. They do not have a charge. So this actually contains most of the atom's mass. So when we talk about the mass of the atom, most of it is located in that nucleus with our positive protons and our neutral neutrons. Now, because the nucleus contains protons, which are positive, and neutrons, which don't have a charge, that means the overall charge of the nucleus is going to be positive. So most of the mass, remember, is in our nucleus with our protons and our neutrons, but outside we have our electron cloud. And this only contains our electrons, which have a negative charge. So our electrons are negatively charged. Now, the electron cloud, if we talk about the electron cloud model of an atom, the cloud is basically the likely location of the electrons. So electrons are not static, meaning that they're not staying still. You can't exactly pinpoint exactly where they are. So when we talk about the electron cloud, it's just the most likely location the electron is, and it's located around the nucleus. And the electron cloud is most of the atom's volume. So not the mass, but the volume, aka it takes up most of the space of the atom. So here is an atomic model a little bit closer up. If you have drawing skills, I would very much recommend drawing this picture right here. Or if you wanted to find a picture of an atom that looks like this and print it out and paste it in your notes, I would do that as well. But either way, we have to know this picture and we have to know the different components. So in this particular image, we're looking at the red particles here. And again, those are the protons and they're positively charged. So if we were going to annotate this, we would use a P and then a little plus symbol. And it's one atomic mass unit, and that's just a unit of measurement. So AMU is atomic mass unit. And this particular atom here is actually of the element carbon. So we have, again, in the red, these are going to be our positive protons, and that's going to be located in the nucleus. And remember, the nucleus has most of the mass of the atom. Our blue particles, these are going to be our neutrons. They have a neutral charge, again, located in the nucleus. They have an annotation of N to the 0. And again, this 0 just means it's neutral. There's no charge. And it's also one atomic mass unit, so 1 AMU, okay? So when we go to find the mass of the atom or an element, all we have to do is add up the number of neutrons and protons, and that'll give us our mass, but we'll talk about that in just a minute. The electrons, again, the electrons are in our electron cloud, which is the most likely location of the electron. Their notation is an E with a negative charge because they do have a negative charge. And here we assume that the electrons do not have mass because they're so light. So it's 1 over 1,840 the size of a proton. So it's a fraction of what a proton's mass would be. So they're so lightweight, we don't even consider them to have mass. That's why most of the mass is in the nucleus, because our protons and our neutrons, they do have mass. They have that 1 AMU, but our electrons, they're basically, we don't even consider them to have a mass because they're so lightweight. All right, so now let's talk about our atomic number. Every single element is going to have an atomic number, and the atomic number is the number of protons in the element, okay? So that's the number of protons in one atom of the element, I should say, okay? So right now we're just dealing with singular atoms. So your atomic number is the number of protons. And the number of protons will determine the element itself. Okay, so that's very important. It's a concept that we're going to take with us, especially into our lessons over the next couple of days. So the atomic number is the number of protons, and it also determines the element. So each element has a unique number of protons. For example, carbon that we were looking at earlier, that has an atomic number of 12. It's always going to have 12 protons. If it doesn't have 12 protons, it's not carbon, okay? So the atomic number is just the number of electrons in a neutral atom, okay? So the charge of the atom is neutral. We'll talk more about when it's not neutral in the future, but for now, all we need to know is that it's the number of electrons in a neutral atom, which makes sense because let's think about it. We'll go back to that example of carbon. If the atomic number is 12 in carbon, which it is, that means there are 12 positive protons in the nucleus, okay? So that means the nucleus has a charge of 12 plus. In a neutral atom, the electrons will also be equal to the number of protons. And remember, electrons are negatively charged. So in carbon, if it's a neutral atom of carbon, 12 electrons, which are negatively charged, and 12 protons, which are positively charged, neutralize each other, so the overall charge of the atom is neutral. Okay, so in a neutral atom, the atomic number, the number of protons, will also be equal to the number of electrons in the electron cloud. Okay? And the mass number is going to be the sum of the protons and the neutrons. So remember, mass, anything that has matters, anything that has mass and takes up space. So the mass is just basically the weight of the atom. And remember, our protons and our neutrons are the only subatomic particles that have mass. We don't consider electrons to have mass because they're so tiny. So if we want to know the mass, essentially the weight of an atom, we would just need to add the number of protons and the neutrons in the nucleus. So for example, if we're talking about carbon with an atomic number of 12, let's say they have 12 protons and 12 neutrons in the nucleus, that means the mass of carbon would be 24, okay? And we're going to do a lot more work with determining mass number, atomic number, number of electrons when we talk about isotopes over our next couple of lessons. But for now, we just need to know the basic structure and what our atomic number tells us. So again, our atomic number tells us three things. It tells us the number of protons, it tells us what the element is, and it tells us the number of electrons if the atom is neutral. So in a neutral atom, how many electrons are there? All right, and so this is just, the last couple slides are just a visual representation of everything that we've learned today and kind of wraps it all together. So again, our proton, the symbol is P+. The charge is +1. Protons are positively charged. The mass is 1 AMU, so atomic mass unit. It is located inside the nucleus, and its relative mass is 1 AMU. Our neutron, they are neutral. Symbol is the N with the little 0. The charge is 0 because they do not have a charge. Also, their mass is 1 AMU, and the location is inside the nucleus. So remember, our protons and neutrons in the nucleus, they make up the mass of the atom. And then finally, we have our electron. Remember, it's located outside the nucleus. The symbol is the E with the negative because it's negatively charged. The charge is -1. It's so tiny, there is no mass. It does have a fractional relative mass, but we're going to assume it doesn't have any mass. It doesn't affect the mass of the atom. And again, the location is outside the nucleus in that electron cloud. Remember, the electron cloud is just the area the electron is most likely to be. Okay? And that's it. So the biggest takeaways I need you to know from today is that protons are positive in the nucleus. Neutrons positive in the nucleus. Neutrons are neutral in the nucleus, excuse me. And then our electrons are in the electron cloud. They don't have any relative mass. They are negatively charged and they exist in the electron cloud. Okay. Also, we need to know that our atomic number tells us the number of protons located in the nucleus. It tells us what element we're dealing with. And if we have a neutral atom, it also is going to tell us the number of electrons in the electron cloud as well. Okay? So if we can remember those things, we'll be good to go for the day. As always, if you guys have any questions, let me know. And if not, you guys are good to move on to today's assignment.